As I say, hand grenades and nuclear weapons, we're close. That's all that matters. Appreciate everybody coming out. Again, this is also my favorite conference because of where it's held and the topics. Last year when I came and attended, I was talking to Bryce afterwards. I said, you got to keep doing this because the content being very AI-centric or moving towards that, and in the cybersecurity space, it just made sense to me. This is where we've got to go. This is where our industry needs to focus. Now, I'm going to diverge from that and go to this topic. The reason I'm going to this topic, zero trust, is when that whole model dropped, a lot of conversations started from the vendor side. And to my friends in the vendor community, I'm not bashing vendors, but the whole concept of, hey, we're now a zero trust solution. We're seeing that same thing in the AI world, right? Hey, we're AI enabled. We do AI. And so I wanted to go into this topic, and I gave this at ISC2's Congress this year, and it went over well. Hopefully it goes over well here. But the idea is when we see something out there that can be implemented, should we implement it? And should we do that to what extent? So that's really the focus of this conversation. Quick about me, I'm collecting merit badges from ISC2. I spent some time in the Air Force, and I like playing in the outdoors, which is why I live in Utah. And I am stupid and I race cars. So now, no one operates in a vacuum. You know, if you're the smartest guy in the room, you're probably in the wrong room. I have requested a lot of information from a lot of people in this process of going down the road and finding out more about different implementations, different approaches to this. And each of these people have really contributed to this, and so I want to make sure they get credit for that. And they're all fun people to deal with too, so good guys. Let's get a quick agenda here. We're going to go through some zero trust history very quickly, definitions and constructs so that we're all talking the same language, and then we're going to explore some implementations. And this is where the rubber hits the road. What are the implementations of zero trust, and what are the implications of those implementations? And then lastly, we'll do a little reality check here. So zero trust history, back in 1994, that's where this term zero trust was coined. The Jericho Forum kind of applied that deperimeterization concept, i.e. we're no longer going to have perimeters. Of course, that was a misnomer because you still just made smaller perimeters, so we didn't really deperimeterize. Operation Aurora is where I think the rubber hit the road. Google got smacked, and they stood up and made BeyondCorp. And they really put a lot of effort into making their systems zero trust, okay? You know, we'll get into that term and what it means. But they did a lot of work on that. And kind of in that same vein is when Kinderberg coined his famous article in Forrester. If you have access to Forrester, there it is. Finding it on the open source is a little difficult, but it is a worthy read, okay? A lot of great information in that paper. So, back to that one. 2020, 800-207 happens, and guess what happened right after that? That's when everyone said, hey, we're now a zero trust solution. Okay? It just, as soon as 800-207 dropped, that's when it happened. So, according to the 800-207 construct, it is a validation of trust at the data and service levels. Okay? That's really what it is. It assumes breach is present. And to me, that's the critical piece, is that we have to get to where mentally we are no longer assuming, hey, I got my firewalls, I'm good. You know, or I've segmented my networks, I'm good. We assume there's a bad actor in every environment all the time. So what's the implication of that? Okay, that's where zero trust comes in. So we're focusing on authorization, or authentication and authorization. All traffic's untrusted. We have an untrusted zone. We have a policy decision and a policy enforcement process to that resource. So those two concepts of policy decision and enforcement are what we're going to start really digging into in the talk. Okay? It's all about those two components. Nothing else is really a zero trust component. This is the diagram that when you open up 800-207, I think it's the second diagram you get to, but within this diagram, the only true components are in that center part. We have the policy engine and administrator, which together are the policy decision point. So that's a decision made, and that is an enforcement point. Now think about that in your network. what are the things that are currently doing those roles? What's actually making a decision for you, and what's enforcing that decision? Those are your current zero trust artifacts, constructs. That's what's doing that work right now. When we get into where this goes, it's where do we put all that? There are required basics, all right? And I'm going to rip through these real fast, but let's just say your security fundamentals have to be in place or zero trust is meaningless, all right? You can put all the decision points and enforcement points in that you want, and if you've got open ports to the internet on a server, I can't help you, right? You know, zero trust is not something that's going to help you in those situations. So all of these basics have to be in place, okay? And I think one of the biggest ones is visibility. Are you logging and monitoring what's going on in your world? Because otherwise, no matter what you do, you're not going to see it. Secure by default is implicit. So all of these basic things that we're all familiar with in the security world still matter. So, you know, again, going back to somebody that comes in and offers you, hey, here's your zero trust solution, is that in this context? Okay? Do they recognize that all of this needs to be in place? So, this is one of my favorite memes. I always put it up, but it does have its reality, right? We spend a lot of time and a lot of money doing things, and then we give some yahoo in the development department admin rights permanently. And then he gets popped, and then our world ends. So, ZT components, again, the policy engine, the policy administrator, those two are your policy decision point. All that means is that component takes all of the signal from all of the different areas where you can gather contextualized signal and put it into an environment to make a good decision on whether or not access is going to be granted to that resource. So those two components, those are the ones that have to make that decision. And so they need information to make that decision. Hence, in that previous diagram, you saw all of those columns down the outside. Those are all your context signals. Those are the things that feed in. The enforcement point is your switch, yes or no. That's all it has to do, is say yes or no. But again, not everything is a ZT component, okay? And when I was working with Patrick at Zscaler, you know, he and I got into an interesting conversation about it in that, you know, they're a proxy, right? They sit out front, and that's how they started. They've actually gone down and developed even deeper things. But at the time, they were simply a proxy, a SaaS proxy. So you logged into Zscaler, and it negotiated conversations with everything else. It said what you could access and what you couldn't. And it gathered context, it did all that good stuff. But I said, aren't you just an IDP? You know, aren't you really just functioning as another kind of IDP? And so we got into the semantics of it. And yeah, functionally, they were kind of both. They made a decision based on identity and then let you have access based on what that identity was assigned as far as its role. So as zero trust evolved, we started to realize that there's a lot of different things that we can extend this to. But through all of this, and I'm just going to go through these fairly quickly, you can get an idea of the scope and scale of everybody getting involved in the zero trust conversation. The thing that never changed was that through all this, you still had to have a policy engine, a policy administrator, and a policy enforcement capability. So nothing changed. We expanded scope, we came up with new frameworks, we came up with all these things, but if we go back to 800-207, NIST defined it and said, look, you still got to have those two components, the policy decision maker and the policy enforcement maker. So implementations, this is where we're going to start talking about how it's built. And, you know, Dilbert's been the geek comic forever, but anybody that's built a great project and then implemented it, this is relatable. It's totally relatable. It's hard to implement, okay? It's great to come up with concepts. It's really hard to implement them. So, whoops, there we go. We live in a world where we used to have pretty defined technology architectures. It was pretty basic. You know, especially when I first went in the Air Force and we had these Unix terminals, and that was kind of everything we did was right there, AS400s. And we knew how that was built. We had a primary mainframe, and everything fed up to our terminals, and we could work in that and call the mainframe and authenticate and get data and do processing, and that was how it worked. And that was kind of what the architecture was globally. I mean, you may have a little bit different network structure, but it was predominantly the same thing. Now, you can almost go limitless as far as what they have available to us, right? Just so many iterations on network architecture and tech stacks, et cetera. But the thing that we always stayed with, even as all of these new processes came in, event-based architecture and serverless architecture and things like that, our security mentality never changed. We kept applying this perimeter-based process to it. We kept saying, put a firewall in place, even internally, let's put a smaller segment, put a firewall in front of that. We kept keeping that mentality that once you pass through the gate, everything on the other side is totally copacetic. You can run in there and do it because we cleared you over here. So from the standpoint of an initial kind of fundamental security platform, we would build an IDP, some way to identify ourselves. We would put some way to protect the traffic and the conversation with the resource to a firewall. The firewall would say, yes, you're able to get in, and it would put us into our network, and we would have application access or whatever it was, we're actually data access. When we look at ZT, the first iteration of true ZT was we built a proxy, and we put it in front of everything, and we said, we're going to take the IDP, and we're going to try to contextualize that. We're going to take other data, like maybe the device ID. You look at Microsoft in our Office 365 environments, and we can do that kind of contextual-based stuff where it says, where was this IP last time it logged in, and where is it today? And look for impossible travel and things like that. So we started getting a little more context, a little more signal into that IDP to make the decision, and then we put this proxy in front of it and said, now you're going to take all that context and make a decision on whether that person has access to this. And this also ended up having a little bit of an SSO kind of model after a few years. We started realizing, hey, we can single sign-on. We can therefore make a SAML assertion and move you into this with even more knowledge of who you are and what you need to do. In e-commerce, because we now have customers, we had a little bit different approach, right? But we still had the same concept. Let's run them through this proxy. Let's get the context to make that decision and then move them into this model. But this is the next thing that started happening. We started figuring out that when we apply zero trust, we should probably keep looking at that. One-time good deal authentication wasn't necessarily the right, or authorization wasn't the right thing. We need to make sure they continue to stay authorized. And so we would ask them to re-authenticate so that they could come through and get authorized again to that specific resource. In the OT environments, kind of the same concept, although we had generally internal network and SCADA networks or ICS networks. And we started looking at it and saying, well, let's do that too. Let's put that proxy in place so that we're negotiating the context of anyone's access to that. So when they come in, are they from the right device? Are they from the right location? All of that kind of context goes in, and we decide whether or not they can get into the internal network or they can also get into the environment for the SCADA. So those were the concepts that we said, let's start doing that with zero trust. The problem is when we started to implement, we learned. And when we learn, we have to realize that we had a few things wrong. So again, here's your dual environment. I've got customers on one side, users on the other, and I have a stack. I have a whole enterprise stack. This is how my company works. And I start looking at that saying, how am I going to really create zero trust when I think of 800.207? Because NIST tells me that I need to go and have a way to tell every one of these kind of resources who has access and who should have, or who should have access and who shouldn't. And when I can make that determination, I can now be zero trust. But NIST doesn't tell me about the problems with that. So I'm going to put a PDP and a PEP functionality in here. Now the first problem is I have to figure out what is that functionality going to be. So in a legacy application stack, I've got an on-prem stack, I've got all the traditional models in there, I've got my servers and database servers, and I've got my app servers, and I've got the databases. Where do I put my PDPs to be able to make a contextualized decision. What signal do I pull in, and what is the actual tool that does that? Well, if I have an API gateway and everything's API, I can use the API gateway to do a lot of that work, a lot of that heavy lifting. It can also be an enforcer, right? I can write rules on that access. But I now have to do that at that level. Within that application stack, are all those applications the same level of access? Or are they different? Do I have different levels of access for different applications? So I have some privileged apps and I have some non-privileged apps. Well, I now have to be able to make that decision with those functions. Enterprise network, same problem. Satellite office, same problem. You get the idea. I now have to start putting these functional tools. These things have to do stuff all the way down into my stack. And the more of these I create, the more complexity I create, and I'm now going against one of the fundamental principles of security, right? You know, simplicity, because complexity makes security much harder. And let's look at microservices. This is another component. So each of those services, theoretically, should be validating access. So what machine can talk to it, what human can talk to it, et cetera. And that's going to come into some kind of queue from all of these microservices and be negotiated in priority, and then it's going to have a decision made on whether or not that access is right. And that includes service 1 talking to service 3. It still has to come out to the point of decision. So this is where we start to introduce that wonderful friend to every IS guy here, latency. Okay? The more we rely on zero trust, according to the model, the more latency we introduce in our ecosystem. So if you think of an application that your customer engages with, latency is a killer, right? They need to be able to get in and engage with that and have a responsive interaction with that that doesn't make them think, man, I'm sitting here waiting and watching it spin. So it behooves us to look at latency as a primary consideration for whether or not we're going to implement zero trust and how we're going to implement zero trust. Okay? As we start to do the implementation phase, the other part of this, there's a fundamental part of security that we should all be doing, right? Threat modeling. But with this, it becomes much more complicated because now I'm taking threat modeling down to every specific location where I've got a policy decision point and a policy enforcement point. And threat modeling, Chris Romeo, again, wonderful guy, really dug into it. This was his kind of focus at ISC2. And he really dug into what threat modeling looks like. Now, he used the STRIDE method. Just put it up here so everyone remembers what STRIDE is. But what he got to was this really interesting effort-based chart. And I took this, afterwards I went up and I said, can I steal this as long as I give you credit? Because it really tells the story of what effort you're going to go into to accurately threat model any given system. So you look at the flows, and as the flows go up, the complexity increases dramatically. The problem with this is, you look at, let's go to the multiple flows, 12 to 40, okay? That becomes pretty difficult, and you know, you're 12 to 40 hours to try to get just a basic threat model done. Multiple flows you've already introduced, to go back to that previous picture, every one of those PDPs is a flow, every one of those PEPs is a flow, and all of the signal coming into the PDP is flow. So let's say you have 5 different signals feeding that to give context, you're suddenly getting to a point where you can't accurately threat model. So let's drill into the various industries from an implementation standpoint. And I just chose enterprise, retail, and OT, because those are kind of the generic models that we go into. So balancing security with customer experience. My user comes in, now in the modern world, I need to do KYC on them, right, so that the banks will be happy with me. And then once I've gotten that validation, they go through my customer identification side, and they get a token, they hit my IDP, and they are then given, that whole access request is contextualized now, it goes to the PDP. And that takes any other data that's involved in that. And generally, I can get KYC data feeding into that as well. and some of the CIAM stuff will go into that. And I contextualize that request, and I get the grant, and I can now get them into my e-commerce shop. Right? So right there is a sequence of things that have to happen just to get me into my e-com shop. Now, as they iterate through my shopping experience, I need to revalidate them to make sure that, that token is still valid, okay? Especially if they walk away and come back, right? It may have expired the token, so I've got to run back through the system. And then we're going to let them, hopefully pay and get out of my system. If we look at the OT side, and I don't know why I went backwards on this one, but I didn't redo it. The users are now on the right. I've got to come into an IDP, okay? And I now go into a zero trust proxy environment, but I've got a SIM now, theoretically, enriching this, right? Because I can run this through my SIM, and as my users interact with me, I can take that logging, that's coming in through that access process, and enrich my PDP with every interaction that that user has. And so I start building a portfolio for each one of my users, and I know what they're able to do. Then, same thing when they go into the IT network, so my basic network for their productivity, or when they start interacting on the ICS side, and they get into the human-machine interface side, and I can start taking feedback from the ICS itself. Did my user interact with the HMI to change configurations, etc.? If they start changing configurations, I can push them back out here and have them re-authenticate to make sure that they're still that right person, that they haven't been compromised, that the enrichment is still valid. And the more enrichment we get, the better off it is. And when we start talking a little later, we'll get into AI and how that can factor into zero trust and make it a more valuable process. It's based on the ability to do this part. We have to be able to get continual enrichment. Whoops, back up one. Yeah, there we go, okay. Then let's look at multi-cloud and hybrid environments. Okay, this is a little bit more your enterprise side. Every one of our cloud providers has some model by which you can exercise their zero trust approach. Okay? It's not going to be your zero trust approach because they built the tool, but you can implement zero trust using these tool sets. BeyondCorp is a very cool thing. If you're in GCP, you probably use it. If you aren't, you should. But it's a very cool product. Okay? And it was born out of their experience during the Aurora attack. So that's something that I highly recommend looking at, even from a conceptual standpoint. We're going to get into Amazon because that's where I currently live, and I'm going to show you how those particular products work. But the idea here is the same idea. I have a control plane with all of this information that I can start gathering to contextualize my users' interaction. Then when they get into my cloud environments or my on-prem environments, I've now built contextualization. And that's the hardest part for us to do, is to build that contextualization. Once we have it, then we can decide how deep down the stack we go. And that's going to be our latency and complexity conversation. So when we're architecting out a zero trust solution, we've got to start with that concept of what's the signal available to me for me to contextualize my access. Then how far down that stack do I want to go? Where's my limitation? And I'll talk to how we get to that conversation in a bit. But real world, AWS, this is how we've approached that model, okay? Getting to my cloud. So, verified access. This is AWS or AVA, Amazon Verified Access. Verified access takes the user's request coming through the WAF, contextualizes it with device trust and user trust. Now, there's various ways to do this. So if you're an Okta customer, you're going to get a package there. If you're a Ping customer, you're going to get a package there. If you're using other sources, you're going to take that information and bring that in to AWS Verified Access. AVA acts as your PDP, right? It gets that contextualization and builds a picture for what that's going to look like. But it also has the PEP side, which makes it very convenient. Because there's no rule that says they have to operate as independent tools. They do operate in different planes, right? One's in the control plane, the decision point, one's in the data plane. But That goes into the application load balancer, and then you get access to the app. When I request access to this app, it's going to take me back out to Ava. It's going to recontextualize me and make sure I have the correct authorization to get app 2. And same for app 3, et cetera, through the stack. So using Ava as a human user, and I interact with these environments, that gives me that opportunity to take a cloud-native tool that's built to do the PDP and PEP functions and implement it at this point. But again, every time this happens, there is a piece that is latent. It's going to cost me time to do that, and a little bit of compute. VPC Lattice is what they've built for machine-to-machine, okay, and inter-VPC conversations. So if I've got these two different environments, I want them to be able to communicate with each other, but do so in a zero-trust model. I put VPC Lattice in the middle of it, and as that system wants to talk to this system, the rule sets that are built in VPC Lattice analyze that request. Is that request contextual to what the rule says? So I build my policy there, and it also enforces my policy. So it's a pretty straightforward model. What it looks like when you have that as a kind of unified environment is that. Okay? My users come in, they're going to interact on this plane in the VPC, but then when the machines have to talk to each other to feed information back, it just goes back through this same model. So Lattice takes care of machine to machine, Ava takes care of human to system. Whatever you build, you have to have this kind of construct in place. Because otherwise, the human user gets in, and if they're nefarious, but they get to the machine, and the machine isn't contextualized, once they got the machine, they can interact with that and cause the machine to nefariously act with other machines. Okay? So, you know, I'm going to ask a real quick question I should have asked up front. Who here is hands-on keyboard in their job? Okay, a few of you. And who here is administrative, management, executive? Okay. That's one of the things that I want you to walk away from with this, is that as an administrator, executive, et cetera, these are the questions you have to start asking your hands-on keyboard guys. Okay? Is how are we taking care of our zero trust model? Now, you may not be doing this, but I know that in our case, our CEO came in and said, guess what? I like this concept. I think we should be doing zero trust. Great. I, at the time, didn't have the answer on what that meant. I said, great, yeah, we'll look into it and make it happen. Then I realized that maybe making it happen wasn't going to happen. Okay? Because the depth of impact to our architecture was significant. So we had to decide, what does it mean to implement that? So real quickly, where does AI factor in? You know, I stated here, ZT, zero trust, is a concept. It's not a technology. So we can apply anything to it. And there's wonderful opportunities at that PDP level to use AI to make really accurate decisions over time, particularly machine learning in that model. We were talking about that in the other thing, is how do we get machine learning to make the right kind of decisions and grow in context, to train itself as a user interacts to be more and more accurate. So looking at it from you've already got this built out system, this is what it looks like today, and you're thinking, where am I going to put AI in this model? Well, we're going to have behavior logging that's going to come out of all of this. So every interaction, every call, everything that happens is pulled into that. Then that moves up into an AI analytics engine. And that's probably going to be a machine learning engine that's going to contextualize all of that and try to train on what's good and what's bad. Okay? And then that's going to go back into the policy engine. Okay? That context feeds back in. So this is where I think we're going to see this, and we're trying to train models right now. And being the guy that has to watch the same YouTube video 10 times to really get something, and then I have to go try to figure out how to implement it, it's not going as fast as it could, but we're making progress. And the idea is we want to be able to have AI do a lot of the PDP function, okay, within certain areas of our environment. Because over time, it should do it more effectively. I don't think it's going to do it faster. So I still have to consider latency, but it's going to do it better. So I'm going to have a higher quality with a little bit of latency cost. So the reality of implementing ZTA, according to 802.07, first question you have to ask is, what's my protection level agreement with my company? Now, who here has heard of a PLA? Okay, it's a relatively new term. This is the protection level that you as a security practitioner or organization have told the board of directors or the executive council that you're going to meet. So what's a protection level? Well, the way we defined it, and we work with them, is that we will spend this amount of money to make it so that any given interaction of a threat actor with our company should only cost us X. That's my PLA. X is my PLA. So let's say, for argument's sake, it's $100 million, okay? Well, if I can lose $100 million and call it good, I only have to spend a certain amount of money. But if you move that down to $10 million, I have to spend a significant chunk of change to get there, like exponentially different, to be down to the $10 million loss range. So the PLA is the first thing you have to determine, because that's going to tell us how deep down the stack we really need to be implementing our ZTA functions, our PDPs and our PEPs. So if it's a $10 million loss, and you're a multi-billion-dollar company that's multinational and you've got different offices, multi-cloud, just back up and think of scope. What's that going to mean to protect down to $10 million? You're going to have a whole lot of functionality spread across everything, down to the Kubernetes pods. You're going to have PDPs looking between containers and justifying conversations between those containers to ensure that nobody can compromise even down at that level. So how much is it going to cost? That's the argument you have. And each cloud, of course, has a different ZT model that we talked about earlier that you're going to have to train on, because your teams aren't going to know all of them. They're probably going to be like me and know AWS fairly well, but maybe not Azure. Okay? So
you're not talking to your leadership then, you're talking to your lawyers. Is the lawsuit higher than what's going to cost you to put that in?
We work in a public company, and so the board of directors is largely bankers and lawyers. And so when we have those conversations, it's very much a legal conversation. And developing that PLA was the only way we could come to a good agreement on what we should be spending. So, yeah.
So how does that correlate with your risk appetite and setting?
It's directly, that is the risk appetite. Yeah, so the risk appetite is an attacker can come in and spank my company up to this dollar amount. Okay, anything beyond that, I've lost my job. Okay, so I've got to keep it right there or below. But I only have the dollars to get it to there. Okay, and it's a soft art, right? It is not hard science. There's certainly a way, one of the things that we did bake in is how much downtime costs. Because it's an e-commerce platform, I can pretty much look historically and tell you what every minute costs. So when we look at resiliency, and we're building resiliency in, that's, I've actually saw, somebody posted on LinkedIn the other day, this thing of zero trust components, and it had everything. Like every possible security thing we do was in that model, and I thought, okay, he's missed the point. Zero trust is two artifacts, a PDP and a PEP. Everything else is supportive. Okay, resiliency is supportive. All right. Certainly, my ZT products, those PDPs and PEPs, those functions should be resilient. Right? If they go down, they should be able to come right back up. But again, resiliency not part of ZT. But when we look at other environments that are out there that we need to think about ZT on, session management is one of those. Okay? And as we talked about that idea of the customer coming in, what's that token duration? What are we going to do with that token and for how long? When do they need to re-authenticate? That's a zero trust decision. Okay? Yeah, there's other questions to ask, but you think about tiers of functionality. Defense in depth was one of those terms we learned when we first went into security. Defense in depth is It's not part of zero trust, but zero trust is part of it. Okay. And lastly, latency, complexity, and monitoring. Okay. Never have a conversation about implementing zero trust with your team or your management without talking about those three things. Because any zero trust implementation will involve all three. Okay? You can't do ZTA without high levels of monitoring, right? All that signal that's got to come in to contextualize for the PDP, if you don't have that, your PDP is making a decision that is arbitrary. It has to have context. The foundational security has to be there. Okay? You just can't go in and say, I'm going to apply zero trust and not have CIS 1 and 2 done, right? I mean, CIS 1 and 2, what do you have? What hardware components do you have? What software are you running? Because if you don't know those things, you don't know what you're trying to capture as far as authentication goes. You don't know what resources people are accessing. And then my conclusions. Yeah, I actually like a lot of what zero trust has to offer. But when we went at it from the edict of let's do all the things, it became impossible. We cannot do all the things. Zero trust can be implemented really far down the stack. You can have a sidecar sitting on that container, and that's its whole job, is to revalidate. Is the call from that other container in context? And it can do that all day, every day, at a cost, okay? And then the cost is not just compute, it's maintenance and monitoring and all the other things that go with it. If you don't have a PLA, start building one, okay? Figure out what that dollar loss is. Your risk appetite is another term for it, but risk appetite to me is less defined, okay? PLA is an agreement I have with leadership as a security practitioner. And so it's possible, yes, you could do 800-207. You know, you could follow that edict and say, okay, I'm going to follow NIST and do it all the way down the stack. I don't think it's reality, okay? And I think that's, you know, when we talk about is real world implementation possible? Yeah, but not really. You know, I'm going to say that the best option is to get your PLA defined and then build zero trust into your stack at the appropriate level. And working from the principle that zero trust is that section of the product. It's not your IDP. It's not your SIM. It's not those other things on the side. It's that decision point and the enforcement point. Everything else is context. So, we're done. It's finally over. Any questions? I know we answered a couple in the front. Cool. Well, thank you guys. Oh, yes.
Yeah, is PLA going to be more often than not synonymous with your security budget, in essence?
Yeah, I mean, for us it is.
Yeah.
It's how we gauge what money we spend. And if the company comes back and says, you know what, we're not comfortable with the dollar amount that we agreed upon last year, I adjust. But that's our line in the sand. And there's other ways to do it, but I just think it's a really good model because you now have, and it's documented. This is what every board meeting we say our PLA is X, it's up in the upper right-hand corner of the slide, and here's what we're doing to get there.
So when we talk about zero trust in the context of user experience, you know, just with my peers, I've heard some users are getting challenged all the time. Hey, are you there? Are you there? Is this you? Hey, are you there? You know, they're always being interrupted. Yep. Versus my take is make it as transparent as possible. Nothing's changed. And so like, what's the right?
So your last statement in my mind is always the right statement. The more transparent we can make security, the less our users know it's there, the better off we are because they won't complain. Now, it doesn't mean, hey, gates are open, have a blast, you know, have a nut, go for it. But it means we try to build that process. So in zero trust, we only make them change up and re-authenticate when the context has changed to the degree we find that there. So you guys are familiar with the concept of a trust logic ladder, right? You know, or a trust matrix. You're building in all of the different items, those context items, the signal, and saying, well, if this signal changes, it's a 10 on a score of 1 to 100. If this signal changes, it's 80 because it's super significant, right? So, you know, MAC address, right? You've got your device ID. That device ID was authenticated at the initial authentication, you authorized them in, and then suddenly the MAC address changes. You know, that doesn't sound right. So now we got to go back and say, please re-authenticate. You know, let's do this again. But if you know, if the browser changes, that's not necessarily that big a deal. You know, they could have just decided, no, I'm going to just switch over to Chrome or whatever. So you just got to look at what those signals are and what level of trust importance you place on those to make the decision on whether you're going to make that call for a re-authentication.
You had a slide on factors and then complexity to implement.
Yeah.
Is there a bang for buck value in there?
The trend or the point of the slide is more to say it is a significant conversation for you to have with your team when you start saying we're going to implement sidecars on our Kubernetes stack. Okay, what does that mean for threat model? You know, how many pods do you actually have? And what is that, if you're going to do it across the entire ecosystem, how many times is that going to be evaluated, because each one's maybe slightly different. So it really is just, it's a guideline to tell you the more you implement down into your stack, the worse it's going to be for you. And you're not going to be able to accurately threat model. Cool. Well, thank you guys. Appreciate it. The powder's calling. So.